Okay, well, thanks everyone for coming to Content Delivery and see our presentation. TouchStream, we're streaming a live stream monitoring tool, and so basically we test live streams. So our typical customers are people, big pay TV providers who have TV Anywhere platforms, or Pure Play, where things like Yip TV. And our telcos are another, and CDNs also use our services. So what's this all about? It's about live streaming, and why is live streaming important and the quality of the experience? Well, live streaming is important because it's really hard. It's not VOD. VOD, you encode VOD and you put it up on your CDN, and you QA it first and you check everything's okay. If there's something wrong, you re-encode it, whatever. Live streaming, signal acquisition through your encoding, your packaging, DRMs, all of those good stuff, eventually to your own origin, and then you out to the CDN. All that's got to happen continuously. And if anything, you've usually only got 30 seconds to a minute between signal acquisition and delivery. Anything goes wrong, you need to know about it, well, preferably beforehand. So that's what we're doing now. Just a quick little video clip for you.
Hey, we've got a problem here.
What did you do?
Nothing, I stirred the tanks.
Whoa. Hey.
This is Houston. Say again, please.
Houston, we have a problem.
Okay, so it's just a little clip I like. It's not really about video delivery, but the point is, it's when you have a problem, you've got to know about it really quickly. You've got to try and figure out what's gone wrong and where it is that you've got to start working on. Yeah, as I say, just like the clip. It's a great movie too. So, some numbers. If you've been in the keynote, you've already seen these numbers twice. But as we all know, the reason we're here is that online video is very big and is growing very rapidly. So it's something that we've all got to take very seriously. And the internet traffic side of it, there's going to be congestion. There's going to be lots of things that are going to happen as this grows. Is everything going to scale out? Well, you're going to need to know. That's the most important thing, is you've got to need to know. So those were the numbers you've already seen. Some that you haven't seen so far today, but you probably will see later on in other presentations, are what the scary numbers are. And these numbers are now getting around quite often in quite a lot of video reports. But basically, if there's poor quality, people will abandon it, and they're not going to, potentially not come back. If there's other ways of getting content, they won't do it, or they'll subscribe to a different service. So there's, as I say, lots of data out there to show that people are very fussy and will seek out alternatives. So then we've got the numbers from a CEO or CFO's point of view. So basically, for very big events, you can have a couple of 100,000 subscribers. We know this from some of the big events we do. We have a very big sports UK customer, and they actually get 200,000-300,000 for a Premier League game. It's not uncommon at all. So those big games, people pay a lot of money for. So, and they do a lot of them. So, and a lot of these you can buy a season pass, or you can buy a pass for an individual event. So these passes can be $10 or more or less. And basically, if you go back to the numbers we had before, the number of subscribers that can be affected by buffering. With what they'll do to abandon, you've got your additional cost, which is a really interesting one, which is the $13 to handle a customer service call. And people often forget about this number because they're all worried about, we're losing subscription. But it actually also is costing you a lot of money when people ring up to complain. And quite often, people will request a refund. Again, we have this from very reliable from reality, and just on huge numbers like that, you can see that very quickly these numbers add up to be very significant cost. So this is the actual problem. People stall videos out of sync, missing audio, or just plain not working, and people get very angry very quickly. So the question comes, what if you knew about these problems before the customers complain? A service like ours, we want it to every bit rate, every minute of every day. We want all the channels, all the formats, and we can quickly identify what the potential root causes are. So what's the point of that? Well, the point would be to reduce the abandonment rate. If you could do that by 25% or so, what would that really mean? And we'll get to that in a minute. But just very quickly, how our service works is, and I haven't got a laser pointer, unfortunately, but we have in the middle we have our main platform, which is our whole service is cloud-based. The main part of the platform lives in Amazon, and then we have our cloud polars, which are off to the right-hand side. And these are the things that do the testing. So the great thing about that is we can distribute them anywhere. We've got literally hundreds of them out there spread across the world. And we can test the endpoints for the CDN endpoints and also the origin endpoints, which is another interesting way of looking at it, because by testing both CDN and origin, you can see if the problem is actually started at the origin, or if it's and therefore look towards the origin and look internally on your encoding side. If it's only at the CDN, then that's really it's in that delivery part of it. So look there. So this is already a quick go left or go right. The point again is reduce your mean time to repair. Reducing your mean time to repair means you'll get happier customers, and that's really what we're trying to do, is reduce that mean time to repair. So that's our platform. It's, as I say, very distributed, particularly from the polling side, and it can be anywhere in the world and test any stream from any CDN. Okay, so what we then do is we present dashboards and all sorts of good stuff that basically are pulling you into to try and figure out exactly what went wrong. And we do a lot of capture. We capture everything that we do, so we can actually, you can see all the actual request that was made, what all the DNS and all the different timings, the standard sort of network centric metrics. So we're capturing all of those metrics, telling you how long each bit rate takes to download. But that's the important thing, is that we are testing every bit rate every minute. So it's kind of different to, and it's also active, so we're polling. So it's very different to the in-player monitoring tools, which are great, by the way, but there's a couple of significant things that they do differently. And the first is that they rely on people playing the video. So if you can look at the problems before people connect to the streams, and particularly sports, we do a lot of sports. If you can look at the streams before people start watching them, and those encoders are all up and running, at least half an hour, if not 24/7. But they're up and running before the event starts, and the app that you watch them from basically doesn't let you sort of click on the watch now until it's ready. So we're testing that stream way before it's actually playing in the player. So an in-player solution can't check it till actually you can start watching it. Now with any sporting event, you start watching it at the start. Then in the first 5 minutes you find out that it's all not working very well. So your problem is, well, that's when you start trying to solve the problem. Well, it's too late, because most problems, I bet you all know enough about technical problems to know that technical problems don't get solved in 5 minutes. They take hours to solve. So, you've lost the game already. So that's one thing. The other thing in-player does differently is that it's only really looking at the bit rate that you're playing. So if, and believe me, we've been doing this for 2 years now, and we see lots of single bit rate issues. So that has different effects depending on which bit rate fails. So if you've got the top bit rate failing, it means you're going to have a quality issue. It means your ABR will never be able to get to the top bit rate because it's not working. So, but the in-player analytics will say everything's okay because ABR would have gone up as high as it could go. It might tell you that you're not playing at the best bit, or that your average bit rate is a bit low, but you can't tell that the reason for that is that the top bit rate's failing. So it's a very different test. And then you've got the other side of the equation. If it's the entry-level bit rate that's failing, it means no one can actually even connect to the stream. So that'll be the classic video starts. But you don't want videos. You don't want your in-player analytics to tell you video starts as failing because it's too late. It's too late. So that's some of the kind of the key differences, between in-player monitoring and our sort of active monitoring. I suppose the other thing is that we class ourselves as operational analytics. So we're things that you can do something about. So our primary customers are the operations groups. We intentionally don't really care about the last mile, but that's not what we do. In-player does that. And the difference is, it's very interesting to know all of that stuff and to classify how your viewing audience went, but that's not very interesting to the operations people. It's more interesting to the business people. You can't do anything about the last mile. Just because T-Mobile's not working very well, there's nothing really that can help you. You can't do anything about it. The things that we do are actionable things. So we're telling you about CDN, which means you've got to call up your CDN and complain and get them to fix it, or your own encoding. So these are operational activities. Okay, so what we're doing is we're presenting you with these dashboards. They're very high performance. They're getting really in depth. They help you. We do a lot of header capture things as well, so we can actually look for interesting, very technical little issues that might manifest themselves, which will help you get to the root cause of what it is. Actually, one of our biggest customers, which is Sky in the UK, they actually inject at the encoding point. They inject the name of the encoder into the headers of the encoding. So it means when they have a problem, they can actually tell which encoder it came from, so they can very quickly go back to where it was. So it's it's very, very in depth. So just a couple of little case studies mini case studies that we did, just to sort of highlight the different types of things we do. So we have our wonderful AFL in Australia. For anyone who hasn't seen it, it's a fantastic sport, very, very action-packed, and it was the issue I alluded to before. Basically, before the game, their encoders are working 24/7. They never actually switch them off. They just patch in the right DVN signal into the encoder, and the rest of the time it streams a slide. So we're actually monitoring that end-to-end delivery, all the way through encode package, all the way to the end, all the time. During the finals, so this was a very important period of time, during the finals, on the morning of a final, which typically starts about 2 o'clock in the afternoon, at 5 a.m. we detected a problem. And basically that gave them, how many hours that is, 5 hours 7 hours to look for that problem. They fixed the problem in 2 hours' time. So then, we're a slightly lower population to you, but those games are 20 to 30,000 viewers for the streaming platform. So they fixed the problem, and basically the game streamed well. It took them about 2 hours, I think, to fix the problem. Well, the game's only 2 hours. If you depended on in-player monitoring, no game. The other one was interesting. Was a pay TV operator in the UK, and it's actually, sorry, they should say a packager there. So they had this really bizarre problem of getting 404 errors on their fragments on smooth streaming, And basically, well, actually, customers don't know they're getting 404, but it was just failing, and not failing consistently, across the board. They have, for their smooth streaming, they have a primary and secondary encoding chain, and basically, it's anyone who understands the minutiae of technical details of smooth streaming. In the manifest is a T number, which is the time, which basically breaks up what the byte alignment is for the fragment. The primary and secondary encoding chain got slightly out of sync in timing. So the manifest from one side of the chain had a different T number to the other side of the chain. It was out by a couple of nanoseconds. And what that meant, it would play fine for a while, but if anyone connecting to the stream, if the CDN switched to the secondary chain, which it would do automatically if it was having any sort of problems, the byte alignment would be wrong because it's got its manifest from the primary and trying to get a chunk from the secondary, and of course this would just stop the player playing. Almost impossible to tell that any other way than with our type of monitoring. So that's the sort of really in-depth detail that we can go to tease out these sort of problems. And this problem had we solved this problem when we first started doing work with this customer. And they'd had people complaining for like 6 months that at odd times just random things happened. And eventually, it'd be on a specific channel. So what they would end up doing, because get so many customer complaints, they would actually reboot effectively everything in the encoding chain and the problem would go away. So that was a big outage that they'd have. Once we detected it and we could actually tell them, we compare the T numbers to each one, all they had to do was basically, once they detected the problem and at the time it actually occurs, it's, the chances of the CDN switching to the secondary are only, they're not high. But so nobody had even seen a problem. All they had to do was do a resync on their halos, and the problem would be solved, or the cause of the problem would be solved. So no outage, no customers affected, and they were detected as soon as it happened. So this was a massive win for them. Okay, so yeah, just doing a little bit of the numbers again. Back to the same numbers that we had before. And so if you could reduce your abandonment by 25 percentage points, technically you could save lots and lots of millions of dollars. I mean, you have to do the numbers for yourself and in your own environment, but the basic matter is that you can reduce the number of, you can basically, the return on investment can be quite significant just by reducing your abandonment rate. So that's all I have for you. If there's any questions, yeah, let me know. Yes. How do we do it? It's an active monitor. They're robots, effectively. It's software. So
Do you monitor the CDN? Do you monitor the border gateway protocol?
No. We monitor by the manifest, right? So every format has a specific manifest, and you configure the top level manifest for smooth, dash, HLS, whatever, in our system, and it just then goes. It understands what all.
How do you predict it? How do you know? You said you can predict it before it happens.
Yeah, well, okay, so the single bitrate errors, they're probably the best ones of predictors. So there's two things that are good predictors. So we do predictive buffering, so we're actually timing the speed all the time. So we're actually showing you as the speed is starting to increase, the time to download speed, this is a predictor of buffering.
You're looking at the individual manifest stream when you do that.
Yes.
But if I'm going here and you're looking at the manifest stream from the originating point, how do you know how?
Yeah, as I said, we're operational analytics. I mean, it's a very good question. Yeah, we can't predict what's going to happen with the ISP, with the last mile.
Okay.
Yeah, we're not predicting that. We're predicting, and again, it's operational, is something within your control going to cause buffering? Right, and so that's monitoring the CDN front door. That's what we like to think, CDN front door.
So what percentage of that actually affects the endpoint? In other words, you want to take this 50% churn rate down to 25%.
Yeah.
How much of that actually happens at the manifest origination point as opposed to happening at the endpoint?
Yeah, that's a really good question, and you're probably sort of getting to the chink of the numbers, which are, yeah, I'm not, they're kind of indicative numbers, but you do go really cool. It's hard to say. Yeah. Oh, okay. Sorry, if you could grab me afterwards, and if not, if you're here for the rest of the conference, we're actually exhibiting, so we have a booth. Thank you.